Hello students. In this lecture, we will discuss about accommodation of eye, dark and light adaptations of eye, and some common defects of eye and their corrections. At first, accommodation of eye. Accommodation of eye means the process of focusing of eye to see objects at different distances. So, for distant object, the lens is relaxed, means it is less convex, and here the light enters to the eye lens, refraction takes place, and finally this rays reaches on the retina or on the yellow spot to make an image. So here the lens is less convex to see distant object, but in case of near object, the lens becomes too curved, means more convex, so that when light rays come from near object to the lens, here refraction takes place, convergence takes place, and then the light rays reach on the yellow spot of the retina, and here image forms. The image formed by the eye lens is real and inverted. So the yellow spot, which is located at the center of horizontal axis behind the lens on the retina, is the best vision area. So light rays reach on this yellow spot, and here an image forms. And in this way, to see distant or near objects clearly, some changes take place, and it is known as accommodation of eye. So focusing of our eye to see objects clearly at different distances, such as distant object or near object can be seen clearly, and this adjustment is known as accommodation of eye. During this accommodation of eye, ciliary muscles play an important role. Ciliary muscles play an important role because here two different types of tissues are present, radial as well as circular tissues. So these two different types of tissues help in adjustment of the lens by contracting or relaxation. In this way, the shape of the lens alters to see near object as well as far object, and it is known as accommodation of eye. Now, how do we see an object? How do we see an object? How do we see an object? When light enters from distant or near objects, which is incident or reflected light, at first entry of light takes place. So you can say, how do we see an object includes a number of steps. So first step is entry of light. Second, refraction of light. Here refraction means bending movement of light. Our lens is convex, so it is converging lens. So convergence takes place. And finally, the light rays after convergence from cornea as well as from the lens reach on the retina. At the retina, here at the retina or yellow spot, image forms, and this image is real and inverted. So real and inverted image forms at retina, and after it the impulse from the retina through the optic nerve, it is optic nerve, goes to the visual zone located in the brain, or you can say cerebrum of the brain, and here interpretation takes place. Interpretation includes again inversion of light, inversion of an image, means the image formed at the retina is inverted, real, but we can see upright image of an object, and it is caused when in the brain interpretation takes place. So interpretation takes place in the cerebrum, and after it we can see the objects clearly, and optic nerve helps in carrying the messages from the retina to the brain, and in this way we can see an object. So there are 4 steps involved. Number 1, entry of light. Number 2, convergence of light. And number 3, transmission of light to the retina. Number 4, formation of image on the retina, and after it transmission takes place of the impulse, and finally we can interpret with the help of our brain, and finally we can see an object. Now, adaptation. Adaptations in eye. Adaptations in eye. There are 2 different types of adaptations: dark adaptation and light adaptation. At first, dark adaptation. When we come from a brightly lighted area to a dark place, then for few seconds we cannot see objects nearby. But after it, there are some changes take place in our eye, and we can see objects clearly. So this is known as dark adaptation. So dark adaptation includes includes 2 changes in our eye. First is regeneration of rhodopsin pigment, which is also known as visual purple. So visual purple or rhodopsin regenerates in the rods, because when we are present in the brightly lighted area, degeneration of rhodopsin takes place, because in the brightly lighted area we can see with the help of our cones as well as iodopsin, which is also known as visual violet. So after degeneration of rhodopsin in the brightly lighted area, the rods becomes inactive. But when we come from brightly lighted area to the dark area, then at first regeneration of rhodopsin pigment takes place because rods and rhodopsins are sensitive to dim light to see in the dark place. And second, dilation of pupil takes place. Dilation of pupil takes place so that more light enters to the lens, and in this way we can see the objects nearby in the dark place. This process is known as dark adaptation. Now, light adaptation. Light adaptation. Light adaptation is the process in which our eye is adjusted to see in the brightly lighted area. So when we come from dim light or dark lighted area to the brightly lighted area, again we cannot see clearly the objects. But after some time we can see in the brightly lighted area all the objects. This adaptation is known as light adaptation. So during light adaptation, the rhodopsin gets bleached and iodopsin regenerates. And second is our pupil becomes narrow. So these are the two changes taking place here. Bleaching of, or you can say regeneration of iodopsin pigment in cones. So now cones become active to see the objects, and second changes taking place here is the narrowing of pupil. Narrowing of pupil is the second step. So narrowing of pupil. Narrowing of pupil, so that in the brightly lighted area the light cannot enter through. So in this way, dark adaptation and light adaptation take place in our eye. In the dark adaptation, once again, regeneration of rhodopsin pigment in rods, and second, dilation of pupil, so that we can adjust our lens as well as eye to see in the dark place, and it is known as dark adaptation. Secondly, light adaptation. When we come from dark place to brightly lighted area, we can't see clearly. But after few changes, few alteration in our eye as well as lens, we can see the objects clearly, and these are number one, regeneration of iodopsin pigment, and second is narrowing of pupil. So after these two alteration, we can see clearly after few seconds in the brightly lighted area, and it is known as light adaptation. Now, some common defects in our eye. Common defects. Common defects of eye. At first, myopia, which is also known as short-sightedness, short or near sightedness. So what do you mean by myopia or short-sightedness or nearsightedness? It is a defect in which a person can see near objects clearly but can't see far objects. What are the causes of myopia? There are two reasons. Number one, increase in the length of eyeball from front to back. And second reason, the lens of eye becomes more convex. So, due to these two reasons, myopia can take place, and it can be corrected by using biconcave lens. So, by using biconcave lens, the person can see objects clearly. So, suppose here formation of image takes place and it is defective eye. Defective eye. So in the defective eye, light enters and the lens is more convex so that the image formation takes place before the retina and the person can see near objects clearly but can't see far objects. The second reason is length of the eyeball. Here length of the eyeball increases. So due to increased length of eyeball, image formation takes place before retina and the person cannot see far objects. For the correction, when biconcave lens is used so that at first divergence takes place, divergence takes place and after the divergence from the biconcave lens, when the light reaches on the convex lens of our eye, again it converges and it forms the image at the retina or mostly on the yellow spot, and so then we can see the object clearly. So it is corrected eye. Once again, myopia is a defect in which the person can see near objects but can't see far objects clearly. It is caused due to increase in the length of eyeball from front to back. And number two, the eye lens becomes more convex. So that before the retina, image formation takes place. It can be corrected by using biconcave lens, so that at first it converges the light, diverges the light, and then when it falls on the eye lens, again it can be converted, and finally the image formation takes place on the yellow spot of the retina. And in this way, myopia can be corrected. And the power of the lens is expressed in minus. Power of lens is expressed in minus. Now the second defective, which is known as which is known as long-sightedness or far-sightedness. Second is hyperopia or hypermetropia or long-sightedness or far-sightedness. It is a defect in which person can see far objects but can't see near objects clearly. Again, it is caused due to two possible reasons. These are: number one, the lens becomes less convex. The lens becomes less convex, and number two, the length of eyeball from front to back decreases. Here it decreases. So length of eyeball from front to back decreases. As a result, the image formation takes place. Image formation takes place behind the eye, beyond the retina. So here image formation takes place behind the retina, and the person can see far objects but can't see near objects. These are the two reasons. After it, how can we correct our hyperopia or long-sightedness? For it, convex lens is used so that when light reaches, at first it converges, and again from the eye lens, secondly it converges and falls on the retina or yellow spot, and here image formation takes place, and the person can see the object near as well as corrected eye. It is corrected eye. Once again, hyperopia or hypermetropia, long-sightedness or far-sightedness. In this condition, a person can see far objects clearly but can't see near objects. It is caused due to two possible reasons. First is the lens becomes less convex, and second, length of eyeball from front to back decreases. It can be corrected by using biconvex lens or convex lens. By using convex lens, a person's eye defect can be corrected. When convex lens is used, it helps in converging the light rays. Again, the light rays can be converged by our eye lens, and finally it reaches on the retina, and image formation takes place on the retina, and the person can see near as well as far objects. Here the power of lens is expressed in plus. In this way, these two common defects, which are very common, can be corrected. Now the third one, is astigmatism. Astigmatism is a condition in which person can see some part of the objects clearly but rest blurred. It is caused due to uneven curvature of cornea. When curvature of cornea becomes uneven, it is uneven cornea, so that some part of the object can be seen clearly and rest are blurred. It can be corrected by using cylindrical lens. So cylindrical lens can be used to cure or to treat astigmatism in which cornea becomes uneven and the person can't see any object clearly. Some parts can be seen clearly and some blurred. After astigmatism, presbyopia. Presbyopia is an eye defect in which person can see near objects blurred and far objects clearly. So it can be considered as a type of hypermetropia or far-sightedness or long-sightedness. It is caused due to the loss of flexibility in the lens or as well as in the ciliary muscles. So when ciliary muscle cannot contract, then the person cannot see near objects. He or she can see only far objects clearly. It can be corrected by using convex lens. So convex lens can be used to treat presbyopia because here flexibility is lost. Flexibility of the lens as well as ciliary muscle is lost. That's why the person cannot see near objects. To see near objects clearly, the convex lens is used to treat presbyopia. Again, some more defects such as cataract in which the lens becomes opaque due to deposition of some dead cells in the eye capsule in the aqueous humor as well as deposition of calcium silicate or calcium carbonate crystals on the eye lens. So eye lens becomes opaque and the person can be blind. So in this condition, it can be corrected surgically by removing the eye lens and it is transplanted by artificial lens. It is an old age problem, degenerative eye defect. After it, color blindness. Color blindness is a genetic disorder which is caused due to defective gene present on the X chromosome and it is also known as X-linked inheritance. And this genetic disorder cannot be corrected. After it, night blindness, which is caused due to deficiency of vitamin A because vitamin A is the major constituent of rhodopsin pigment. When vitamin A is deficient in the body, then the person's eye can't see at night or in the dim light because rhodopsin cannot regenerate in sufficient amount. So in this way, these are the common eye defects, and we can cure all these